All right, today we're putting on our detective hats to solve a pretty cool science mystery. We're going to follow the clues step by step and see exactly how scientists can crack a case, going from just seeing something weird to having a solid conclusion. Let's get into it.
So it all starts with this strange phenomenon called elephant's toothpaste. Yeah, it's a classic science demo, but for us, today, we're going to treat it more like a chemical crime scene. Our job is to investigate what's going on and figure out exactly what happened. Every good investigation starts with gathering clues. And when you watch this reaction, the clues are pretty dramatic. A massive amount of foam just erupts out of nowhere. You can see steam rising off of it. The container gets warm. And maybe most importantly, that foam is just filled with tons of tiny gas bubbles. These are our first pieces of evidence. Seeing all this is one thing, but actually understanding it, that's another. We've got our observations, we've got our clues. The big question now is, what does it all mean? What's the story these clues are trying to tell us? And this is really the fundamental challenge in science, right? How do you build that bridge from just a simple observation, like, whoa, look at that foam, to a real evidence-based explanation? I mean, we can't just guess. We need a process we can rely on. Well, luckily, scientists have one. You can think of it just like a detective's toolkit, filled with all these reliable methods to analyze the evidence, connect the dots, and build a case that actually holds up. So inside this toolkit are some really important instruments. We've got progress trackers, which help us log our discoveries as we go. There are data tables, which are kind of like a library of known scientific facts. And then we have things like key model ideas and anchor charts to help guide our thinking and keep all the important clues right in front of us. Let's focus on one of those tools for a second. A key model idea. This is basically a core principle, a rule that we know we can rely on. And for this case, our guiding idea is pretty simple. A chemical reaction happens when the stuff you start with combines to form new stuff. That makes a chemical reaction our main suspect. Our mission then? Find a new substance that wasn't there at the start. This brings us to our most promising lead, those bubbles. They're a gas. Now, if we can prove this gas is a new substance, something that wasn't there in the beginning, we'll have all the proof we need. But first, we've got to identify it. So, what gas is it? And this is where another tool from our kit comes in, the data table. Think of this as our book of scientific fingerprints. It tells us how common gases behave when you run certain tests on them. If we can test our mystery gas and match the result to this table, we'll know exactly who our culprit is. See that line at the top? A glowing splint will actually relight if it's in the presence of oxygen. So here's exactly how we build the case. First, the observation. We see the bubbles. Then, the experiment. We test that gas with a glowing splint and poof, it relights. Next, data analysis. We compare that result to our data table, which confirms only one gas does this. And that leads to our rock-solid conclusion. The new substance being made is oxygen gas. And just like that, we've done it. By systematically using our tools, observation, running an experiment, and analyzing the data, we've identified the new substance. We have concrete proof that a chemical reaction was happening all along. This progress tracker really sums it all up, doesn't it? We started with these basic questions about the foam and where the gas came from. And now we have answers. The foam is just carrying the gas, and that gas, oxygen, is brand new, created right there on the spot. We've made some serious progress on our case. But here's the most exciting thing about science. Cracking one case doesn't just end the investigation. In fact, it almost always unlocks the door to a much deeper, more fundamental mystery. A really good answer always leads to an even better question. So what is that next question? Well, it's this. We know we made oxygen, but how? What is actually going on down at the invisible level of atoms and molecules? How are the old particles literally rearranging themselves to become new ones? That's the next puzzle to solve. And that's the real takeaway here. Science isn't just about finding the right answer. It's about peeling back the layers. We started with the foamy mystery and found oxygen. But that amazing discovery just opens up a much bigger question. What kind of invisible atomic dance can turn a simple liquid into a gas like that? You see, every answer just reveals a more fascinating puzzle waiting to be solved.